So we're going to review a little of normal distribution of what we saw last unit, but also a little review of the very beginning of our school year when we talk about sample, we talk about population. Population is basically everyone that's affected. Sample is the group that I use. And then we do have a mean of a sample. We have a standard deviation of the sample, as well as we have a mean and a standard deviation of population. So let's actually read this a little. It says, suppose a random sample of 16 measurements is selected from a population with a mean u and a mu and the standard deviation sigma. Okay, so I'm going to use, again, the Greek letters. Mu is our mean and sigma is standard deviation. Now, our measurement is 16. So my population is as big as it is. I have no idea how big is my population. However, my sample is 16. Let me just come and say it. N is equal to 16, right? My sample. Now, for each of the following values of mu and sigma, give the values of mu of the sample and sigma of the sample. Okay, so this little x with the little bar on the top, that's basically of the sample. I remember last week I had us work on sampling distribution of sample statistics, and there was one there was one question where we did the mean of the population, and then we did the mean of a sample, and then it happened to be the same thing. And I was like, I just said on our lecture, I said, that's interesting. We'll talk about that later. Well, that later is right now. The mu of the population is 8. Well, this first example, the mu, the mean of the population is 8. Now that's gonna help me find the mean of the sample. The mean of the sample is this symbol that we have here, mu of x crossbar. That's basically the mean of the sample. Interesting thing is that the mean of the sample, the mean of the population is the exact same number. Oh, so that said, the mean of my population here is 8, so the mean of my sample will also be 8. That's easy. Now, the standard deviation is not quite the same thing. The standard deviation of the whole population is 4, right? We were given that here. Again, the standard deviation of the whole population is 4. Now, the standard deviation of the sample, let me give you guys a formula we're going to be using. For the standard deviation of the sample, we're going to do the standard deviation of the population divided by the square root of n. Okay, n, I've seen that before. Yes, I told you guys at the beginning. Remember how I said let n equal 16. My sample, how big was the sample? So in this case, for the standard deviation of my sample, I'm gonna go 4 divided by, remember the 4 because that's the standard deviation of the population. I'm gonna go 4 divided by the square root of 16. Remember, 16 is how big is my sample. Now, that can also be seen as 4 divided by 4, because the square root of 16 is 4, right? So I just call it 4. Now, 4 over 4, basically 4 divided by 4. I'm just going to call this 1. So the mean of my sample in this case is 8. The standard deviation of my sample in this case is 1. That's not bad. Okay, so let's take a look at the next question. The mean of my population is 64. So the mean of my sample will also be 64. Now the standard deviation of my sample, remember my formula. I'm going to do the standard deviation of the whole population divided by the square root of n. Remember, n is how big is my sample. So in this case, I'm looking at 16 divided by the square root of 16. Or I'm looking at this as 16 divided by 4. Now, 16 divided by 4 is 4. So there. So it's not that difficult to get the mean and the standard deviation of the sample given the mean standard deviation of the population. Okay, so that was a quick review how to, or quick lecture on how to get the mean and the standard deviation of the sample, because we're going to be using this. Here it says, let a random sample of 36 observation. Oh, that 36 is important. So let me just write here the side, and is equal to 36. That's how big is my population. Is drawn from a population with a mean equal to 18. Oh, so the mean of the population is 18, and the standard deviation is equal to 12. Given the mean and standard deviation of the repeated, well, give the mean and standard deviation of the repeated sampling distribution X crossbar. Okay, so let's work on this. The mean of the population is equal to the mean of the sample. So this is 18. Now here, I'm gonna go 12 divided by the square root of 36. Let me work the square root first. So I have 12 over 6, because the square root of 36 is 6. Now 12 divided by 6 is 2. So I'm going to have that the mean is 18. My standard deviation is 2. Now, using that, here it says calculate the standard normal scored corresponding to a value of X crossbarred equal to 14.8. Remember how we used to do X minus mu divided by sigma. And remember, that's how we got our C scored on our previous unit. Well, now pretty similar. To calculate my C scored, I'm gonna do, instead of just an X, we call this X bar. Basically the X of my sample, and instead of a mu, a regular mu, we call this mu of X bar, which is basically the mean of my sample. And at the bottom, instead of just calling it a sigma, I call it sigma of X bar, which basically means the standard deviation of my sample. All right, so these values are all given. So this is, I'm going to look at this as 14.8 minus 18 over 2. Those values I got from a little above. I got them from up here. You guys see my cursor? I got them from right here. My 14.8 is the X that I'm trying, my X bar. My 18, well, that was my mean of my sample. And my 2, well, that's the standard deviation of my sample. So I'm going to do 14.8 minus 18. So that looks like a negative 3.2. I just did 14.8 minus 18. That's all I did. So negative 3.2 divided by 2. And that gives me a negative 1.6. Okay, negative 1.6. We can call it negative 1.60. So just negative 1.6. Now it says calculate the standard normal C-score corresponding to values of X bar 19.6. Okay, so basically kind of like the steps that we did, but instead of 14.8, in this case, I'm doing 19.6. So remember, the way I'm doing this for the sample, I'm going the X crossbar, the number that I'm trying, minus the mean of my sample divided by the standard deviation of my sample. In other words, I'm gonna say this is 19.6 minus 18 divided by 2. All right, so 19.6 minus 18 is just 1.6. So I have 1.6 divided by 2. That gives me 0.8. So it's not that hard to calculate some C scores. Now here, I'm gonna use my probability. Now I remember I gave you guys a table last unit, and I'm giving it back again this week, the C-scored table. So now let's take a look at here. Let me zoom in here. Find the probability that X is less than 14.8. Okay, so my 14.8 I know gave me a C-score. My C-score was negative 1.6. Now, let me see what negative 1.6 gives me first. Let me bring my table. Remember this table that I gave you guys? Okay, so negative 1.6. I'm not looking at the negative sign for right now because this thing gives me all positive numbers. I'm going to read this as a positive 1.6. So 1.6, if I write it using two decimal numbers, is 1.60, right? Like I said, using two decimal numbers. I'm going to look at the up to the first decimal number. So I'm going to look at 1.6 here on the left, and then my 0 here on the top. So 1.6 here on the left is right here. My zeros is right here on the top. So 1.60, it gives me 0.4452. You guys see it? Let me zoom in so we can see it. 1.60 gives me 0.4452. Now this is the probability, the area under the graph from the center, so from mean to the value we're calculating. If my C-score is positive, well, guess what? I go to the right of my center. If my C-score is negative, well, guess what? I go to the left of my center. But my value here, my value here, my probability is going to be 0.4452. That's not quite my answer. That's a value that I have here. So let me come back to our work. Let me zoom in here. Let's say we had this as a normal distribution. And let's say here, right in the center is 18. And then 18 because that's our mean, right? Then I'm calculating 14.8. Remember, we got the C-score of 14.8. Now, our mean is right here in the center. My 14.8 is obviously to the left of it. So that's why it gave me a negative C-score. And then right now, we just found out using our table that the distance between 14.8 and 18 is 0.4452. Right? The distance between 14.8 and 18 is 0.4452. Again, I got that from the table that we just worked on, that we just saw. Now here, I'm asking, what's the probability that is less than 14.8? So you got to pay attention to the graph. And you got to know your inequalities. Less than. So from 14.8 to the left. So less than. So not my answer will not be 0.4452. A couple things I can see here. The whole graph. If I was to combine the whole graph, let's just say this area, like the whole graph is 1. Whole probability is 1. I'm not quite interested in the whole graph. I'm just really, right now, I see that I have information of half of the graph. Okay, if the whole graph was the probability, the area under the whole graph was 1, well, what's the area under half of the graph? 0.5. Okay, I know you guys might think you guys hate algebra, or like when you guys have to solve for x. Let me call this area x, because I'm trying to find what is this area in reality. Let me call this area x. And I know that x plus 0.4452 0.4452. You see how I'm combining these two areas? So x, which is what I'm looking for, plus 0.4452 is equal to 0.5. Oh, how did I get that 0.5? It's the half of our graph. Remember how I said under the whole graph it's 1. So under half of the graph is 0.5. So solve for x. Remember, I have to subtract. So let me go minus 0.4452. I'm going to say x, the area that I'm looking for. I'm going to go 0.5 minus 0.4452, and it gives me 0.0548. I might even ask you round it to 4 decimal places. Oh, there it is. I might even ask you round it to 3 decimal places. That's it. Now let's take a look at the next example. Find the probability that x bar is greater than 19.6. Okay, so what I'm thinking here, let me do a normal distribution. I know my mean is 18. In fact, let me cross all over here. I'm looking at 19.6. Let me just say 19.6 is about here. I know the table that we have is going to give me the area in between 18 and 19.6. Right? I know how to find that. First, for 19.6, I had, let me zoom out a little. Well, not too much. For 19.6, I had a C-score. Remember my C-score for 19.6? Didn't we get a 0.8? Remember that? Okay, so I will use my table. I'm going to look for 0.8. If I need to see this as a 2 decimal place, at 0.80. Okay, so let me come here. Let me erase this. So remember, I'm looking for, let me go in blue so it's easier to see. I'm looking for 0, or let's go white instead. 0.80. The 0.8, I'm going to look at this here on the left. The 0, I'm going to look at it on the top. So that gives me 0.8 is right here. My 0 on the top is right here. So 0.80 gives me the probability of 0.80. It gives me 0.2881. So 0.2881. All right, that's not that hard. Let's come back to our work here. The 0.2881 is this right here, 0.2881. Okay, so I got to understand what my question here says. Here it says, what's the probability that x bar is more than 19.6? So basically, I'm asking for this right here. Let me highlight part of my graph. Since I'm starting from the mean, that means this is only half of my graph. I know the area under the whole graph is 1, so the area under half of the graph will be 0.5. So let me look at this as an algebra question. I'm going to look at this as 0.2881 plus x. And again, x is this area. I have no idea what it is, what number that is. So 0.2881 plus x is equal to 0.5. And again, I'm saying 0.5 because it's half of my whole graph. So this one I have to subtract. So minus 0.2881. So I get that x is equal to 0.2. 0.2119. Okay, that's not bad. And then I'm going to use this last probability, this last question. Let me use black for this one. Let's just say our normal distribution looks like this. My mean is 18. But here I'm asking, what's the probability that X bar is in between 14.8 and 19.6? So let's just say that 14.8 is here. And let's just say 19.6 is about here. It is not drawn to scale, okay? I just put 14.8 to the left of 18, and I put 19.6 to the right of 18. I just put them in order, not drawn to scale. I know from previous work, I know the distance between, the probability between 18 and 14.8 is 0.4452. And I also know that the distance between 18 and 19.6, the probability of X bar between 18 and 19.6 is 0.2881. Again, from previous questions. So now here I'm asking, my bar is in between 14.8 and 19.6. So it's more than 14.8, but it's less than 19.6. So in reality, this is what I'm asking for. There's not that much work to do other than adding those two numbers. So 0.4452 plus 0.2881 is going to give me my probability here to be 0.7333. I just added those two values. And that is it.